How to convert a decimal number to an octal number. In this tutorial, we will describe how to convert a decimal number to an octal number. For example, let us convert the following. So we are going to convert a decimal number to an octal number. For this example, we're going to take the value 673, which is represented in decimal form, and we're going to show that its octal equivalent is 1241. Before we begin the computation, let's look at the notes that we have to the top right. Since we're dealing with octal numbers, we're going to deal with the base 8. So we just need a few to help with the computation. So we have 8 to the 5th power is 32,768. 8 to the 4th power is 4,096. 8 to the 3rd power is 512. 8 to the 2nd power is 64. 8 to the 1st power is 8. And 8 to the 0th power is 1. So we begin the computation. Let's see, we're going to begin the computation by dividing the original decimal value by multiples of 8. Okay, so what we're going to do here is, so we look at the value 673, and what we do, we look towards the notes over here. We have 8 to the 4th power is 4,096, and that is greater than the value 673. So we want to find a value that's the highest value, but not greater than 673. And in that case, it's going to be 8 to the 3rd power, which is 512. So we take 512 and we divide into 673. And 512 goes or divides into 673 one time. And so what we have is 1 times 512 equals 512. And we'll take 673 and subtract 512. Let's see what that gives us. That's a value of 161. And what this shows here, we'll keep this value here is in decimal format, so that's to the base 10 for now. All right, so then we continue to divide. So we take the 161 and we want to also divide that by a multiple of 8. So we want the highest value. We want to divide using the highest value that's not greater than 161. Well, we already use 8 to the 3rd power, and we see that 512 is greater than 161. So the next one here is 8 to the 2nd power. We'll use 64 to divide into 161. So we can divide that by 64, and that's a value of 2. So 2 goes here. And so we have 2 times 64 is a value of 128. And so we'll keep track of the 2 here. So this is still 2 in base 10 right now. So we have product here. Actually, we got to subtract. Forgot to continue here. Let's go 161 subtract 128. And that's going to give us, let's see, 161 subtract 128, a value of 33. All right, so we continue to divide. So we take 33 and divide by a multiple of 8. So we've used 512, we use 64. These values are greater than 33, so we take the next highest value that's not greater than 33. It would be 8 to the 1st power, which will produce the value 8. So we divide 8 into 33, and it goes in or divides in 4 times. So 4 goes here. So we have 8 times 4 equals 32, and we have 33 subtract 32, and that gives us the value of 1. Let's keep track of our quotient. So 4 goes here. And we continue to divide. So we have, once again, we use 512, we use 64, we use 8. So we need another multiple of 8 that divides into 1 that's not greater than 1. And the only one that remains is we use 8 to the 0th power. We use a value of 1. So 1 divides into 1 time. And so we have 1 times 1 equals 1. So that leaves us 1 subtract 1 will produce the value of 0. Hint, hint, hint. This is the stop point right here. So that means we don't have to continue to divide anymore. But we need to keep track of the 1 here. And let's see here. So that's also to the base 10. So now we got to convert each of these to the octal. And what it shows, 1 in decimal is also the same as 1 in octal. The value 2 in the decimal system is also the value 2 in the octal system. The value 4 is also octal, the value in octal system. And the value 1 in decimal is also the value 1 in octal. So thus what this shows is that the value 673 in the decimal system is equivalent to the value 1241 in octal. And this is what we wanted to show. Next, let us perform another decimal to octal conversion. This time we will convert numbers with a decimal point. How to convert a decimal number to an octal number. All right, this time we're going to use an example using decimal points. So what we're going to do is pretty much the same algorithm that we used in the previous one when we dealt with only an integer portion. So let's go ahead and begin the computation. So what we do is we take the value 815 and we're going to divide by the highest multiple of 8 without it being greater than the value 815. And in that case, it's 512, which is 8 to the 3rd power. And 512 goes into 815 one time. So we got 1. We have 1 times 512 equals 512. And so we take 815 and subtract 512. And this gives us a value of 512, 303. Let's keep track of the quotient. And this is in the base 10 up to this point. So we'll continue to divide. So we had 303, and we also want to divide 303 by a multiple of 8. So we want the highest number that's not greater than 303. We just used 512. So the next one would be 8 to the 2nd power, which produces the value 64. So we'll use 64 and divide that into 303. So 303 divided by 64, it divides 4 times. So we'll put 4 here as the quotient. And so let's take 4 times 64. That's going to produce a value. Let's see, 4 times 64, 256. And then we'll take 303 and subtract 256. And this will produce a difference of 47. All right, let's keep track of the quotient. All right, so let's continue. We continue to divide. So we have the value 47. We also want to divide this by a multiple of 8. We want the highest value without it being greater than 47. We use 512, we use 64, and now we're going to use, next one is 8 to the 1st power, which will produce the value 8. 47 divided by 8, it's 5 times. So we have the value 5 goes here. Then we have 8 times 5 is 40. And then we have 47. Subtract 40 will leave the value 7. And at this point here, we'll go ahead and keep track of the quotient. So it's 5 to the base 10. So we take the value 7 and also divide by a multiple of 8. We want the highest value without it being greater than 7. And in this case, it's 8 to the 0th power. So that means the value 1. 1 goes into 7 times. So we have 1 times 7 equals 7. And so we have 7 subtract 7 will leave 0. And this here indicates a stopping point right here. And so we keep track of our quotient. And that's the value 7 to the base 10. So to show the decimal part, all of this part right here, we basically actually use division. So we indicate here that when we dealt with the integer portion, we pretty much divide by multiples of 8. Now when we deal with the fractional part, which would be the value, actually let's erase this right here. Let's go ahead and we can show that here. Let's see. So actually if we did, let's go ahead and convert these over. So let's see, 1 in octal, or 1 in the base, the decimal base 10 is also 1 in octal. And then if we convert 4 in the decimal system, it's also 4 in the octal. When we convert 5 in the decimal system, it's also 5 in the octal system. And when we convert 7 from the decimal system, it's also 7 in the octal system. So at that point there, we have our 1, 4, 5, 7, and this is in octal. So now we have to compute the fractional portion. Now the way to do that is instead of dividing this time, we have to multiply, because we're doing the opposite of what we did for the integer portion. All right. Sorry, that's to be multiply. All right, so what we should do is show that we take the value 0.25 and then multiply it by 8, since we're dealing with octals. So what we have here is we have 0.25 times 8. It produces a value of 2. The same 2 can also be represented as 2 plus 0. And this indicates a stop. So that means we do not have to multiply anymore. So what we do here is this same 2 here is represented here, and thus this indicates the octal that we were trying to show. So thus, we've shown that the value 815.25 in the decimal system equals 1457.2 in the octal system. And this is what we wanted to show. This puts us in a position for my next tutorial, where we describe how to convert from binary numbers to decimal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also feel free to join us here at the Computing Sector. There will be more videos and tutorials coming soon. Thanks.